This starts out as saying we're going from negative infinity to positive infinity of cosine pi t dt. This is an improper integral because I have infinities at my endpoints. There's another way that an integral can be improper, and that's if there's a value that makes the function undefined somewhere on the interval. Those aren't really those types of questions aren't really discussed in section 5.8 of our book, but if you've had another calculus class, you might have encountered that other type of improper integral. For this one, if both of our bounds are improper, the first thing that we have to do is actually break this into two pieces, because we can only deal with one bound being improper at a time. So if I pick a number between negative infinity and infinity, I'll just pick the nice number of 0. I'm going to rewrite this integral as two separate ones. We're going to go negative infinity to 0. Plus 0 to positive infinity. Now what I want to do is take each of these improper integrals and make them proper again by substituting those infinity values for limits as something approaches infinity. Doesn't matter what the variable is, I'm going to choose a and b. So I'm going to swap out that negative infinity and instead write that we're taking the limit as a approaches negative infinity. And then on this integral, I'll get rid of the infinity up there, swap that out for a constant, and take the limit as b approaches positive infinity. For any of our improper integrals, we still have to find the antiderivatives, and nothing has changed about how we're going to do that. If I'm looking at cosine of pi t, I'm thinking to myself, who's the function whose derivative is positive cosine? And that function would be sine. As with any trig integral or derivative for that matter, calculus can't change what's the argument of the cosine. So this is going to become sine of pi t, and then I'm correcting for that chain rule by dividing by pi. We're going to evaluate this from a to 0, and we're taking that limit as a approaches negative infinity. I'm adding this to the limit as b approaches infinity. Since these were the same integrand, my antiderivative is going to be the same over here, and I'll have sine of pi t over pi from 0 to b. If I plug in these limits of integration, I get the limit as a approaches negative infinity, sine of a pi over pi minus, when we plug in 0 for t, sine of 0 is 0. Over here, I'm going to take the limit as b approaches infinity of sine pi times b over pi minus, again, when I plug in 0, sine of 0 is going to be 0. If we think back to 17a, the limit as a approaches infinity or negative infinity, for that matter, of sine of infinity, that's undefined. And because that limit is undefined, we're going to say that this integral is undefined. And if it's undefined, the word that we use for the improper integrals is to say that it's divergent.